Welcome to this session. In this session, we discuss how to count solutions of a linear equation in variables x1, x2 up to xn, where we are only interested in non-negative integer solutions for i's. So the theorem states the number of solutions of this equation in non-negative integers xi is given by n plus r minus 1 combination r. So this is the definition. So the key term says that. So remember, by default, this r is non-negative integer. For this to be applied, and then n is the number of variables whose integer solutions we are interested in finding. And so to define or to count how many solutions there are in total, to carry out this number of combinations. So an appetizer, how many solutions does the equation x1 plus x2 plus x3 equals to 11 have, where x1, x2, and x3 are non-negative solutions. So this is the question mark. So provided that x1, x2, and x3 are non-negative integers, then the theorem above will apply. So the key thing is that for you to apply that formula, then you have to see this non-negative integer solutions. So solution here. So n, 1, 2, 3, we have 3 variables. R, the constant on the right-hand side is 11. So therefore, number of non-negative integer solutions of the given equation is, so it's n plus r minus 1 combination r. So we should be 3 plus 11 minus 1 combination 11. So we should be 3 plus 11 is 14 minus 1, 13. Combination 11, which is 13 factorial over 11 factorial into 13 minus 11 factorial, which is 13 times 12 times 11 factorial 11 factorial times 13 minus 11 is 2. Factorial just this minus 2 times 1. Now with this and this cancels out. This one is 11. And we get 13 by 11 is 140. Okay. So we have 13 combination 11. So this is 6, not 11. Sorry. So the number of times 2 divides 12 is 6, not 11. So we get, so this is 1, this is 6. So 13 times 6 is 70. 78. So 78 solutions. So that's what we get for that problem. And then number 2, so how many solutions? Remember here, we are not listing the solutions themselves. We are just getting the number of how many they are. We're not being specific to get each of them, but we are counting just the number of solutions. So this is another problem. So you see we have 3 variables. So the key term for us to apply that formula, you have to see the word non-negative integers. This is a key term. If we are not dealing with non-negative integers, then you have to transform the problem to have that same meaning of non-negative integer. So here, n, there are 1, 2, 3 variables, and the constant term r is 17. So number of solutions will be n plus r minus 1 combination r, which is n is 3, r is 17, minus 1, r is 17. 3 plus 17 minus 1 is 19. So 19 combination 17, which is 19 factorial over 17 factorial. 19 minus 17 is 2 factorial. So this will give us 171. So that's what you get. And then lastly, number. So example, how many solutions are there of x plus y plus z equals to 17 in positive integers. So note that to apply the theorem, you need to have, or you need to be dealing with non-negative integer solutions. So this is a key term. So you are not just going to say n is 3 and r is 17 and put into the formula and then you think you have the correct answer. You have to retransform the question to have the meaning of non-negative integers. So remember, when you say non-negative, we are including 0. If we say positive, we are excluding 0. So therefore, to solve this, you say here we require, when they say positive integers, 0 is not part of the solution. Positive does not mean the same thing as non-negative. So here we require x to be greater than or equals to 1, y to be greater than or equals to 1, z to be greater than or equals to 1. That's the meaning of positive integers. So you start from 1 going up. So we need to retransform the equation to have the meaning of non-negative integer solutions. That's very key. Now, so remember, when you say positive, you're starting from 0, but non-negative, 0 is part of the solution. So it means we can write, so we put x to be 1 plus u, y to be 1 plus v, and z to be 1 plus w, because the number of units from 0 to 1, which is first positive integer, is 1. So like the value of this one is 0. So this is another way of rewriting starting from 0 instead of 1. So therefore, which implies x plus y plus z will be 1 plus u plus 1 plus v plus 1 plus w, which will give us u plus v plus w, which are then plus 3. And then this will give us 17 from the equation. Now you see the condition given the equation that positive integers, when you replace this for 0, this for 0, this for 0, then it will still work. So it means that then there's a possibility of u being 0, v being 0, w being 0. So therefore, if you use the variables u, v, and w, then they respect the condition non-negative. So which means u plus v plus w is 17 minus 3, which is 14. And so we seek solutions in non-negative integers u, v, and w. So therefore, the number of solutions is, so this is the equation that now we solve according to that theorem. So n is 3, r is 14, minus 1, 14, which is 17 minus 1 is 16, combination 14, which is 16 factorial over 14 factorial times 16 minus 14 is 2 factorial. That we get 120. So we have 120 as the solution to that problem. Thank you.